In this problem, we have a disk with a hole at the center. The disk is positively charged with uniform surface charge density sigma. The inner radius is R1 and the outer radius is R2. Eventually, we'd like to calculate the electric field at point P that is arbitrarily located on the x-axis. Now, in part A, we want to calculate the total charge on the disk in terms of the surface charge density sigma. Now, sigma is defined as total charge divided by the surface area, right? So that's the definition of uniform surface charge density. So total charge, I'm going to call that capital Q, divided by A, that's the surface area of this shape. And we're looking for capital Q, total charge of the disk. Now, what is the surface area equal to? That's equal to the larger disk with radius R2 minus the surface of the hole, the area of the hole, which is the area of a disk with radius R1. So basically that's going to be equal to pi R2 squared minus pi R1 squared. Pi R2 squared, that's the area of the larger disk, minus the area of the hole, the missing part, pi R1 squared. So this is the answer basically. Let's simplify the denominator to make it look a little simpler. Factor out the common term pi. So sigma is equal to Q divided by pi in parentheses R2 squared minus R1 squared. R2 squared minus R1 squared. I'm looking for capital Q, so let me rearrange this equation and isolate Q. Multiply both sides by the denominator basically. So capital Q, total charge on the disk, is equal to, in terms of the given variables, sigma times pi times parentheses R2 squared minus R1 squared. So this is the total charge on the disk in terms of the given variables in the problem.